Chris.
Thanks, Jen. All right. Oh, hello. Let's get this going. Hello, friends. All right, I'm Chris Lawson. I'm a postdoc at UQ with Pete Mumby. So I'm going to talk about the Great Reef Census, which is a project. So the science communities combined of UQ and JCU, and it's run by Citizens of the Reef, who are NGO based in Cairns, who I think most of the team's here. I'm going to quickly fly through this because I've crammed so much in there. I'll try to get through the methods quickly. Andy, the CEO of the NGO, Citizens of the Reef, is giving a talk tomorrow, which should give a little bit more of the conceptual background as well. All right, what is the Great Reef Census? So where did this come from? So it sort of arose a few years ago as a response to the mass bleaching. Here we are again. And so it was started by a group of scientists, reef managers, not-for-profit Citizens of the Reef, as well as traditional owner groups, tourism partners, and so it fits very well in this theme. And it's the whole point is basically inform the resilience-based management that everyone is talking about here at this conference. So it provides information for that. And so what's the point, right? Is broad-scale reconnaissance, right? And so rather than, it's not trying to be the AIMS long-term monitoring program, it's not trying to get really, highly detailed species-specific data at, particular locations and track that through time. It's kind of trying to cast the net very wide and get sort of relative changes in coral cover, but across very large areas, and doing it cheap, flexible, and engaging. So cheap as in there's a lot of volunteers, there's a lot of leaning on technology to try to make it as efficient as possible. Flexible as in it can sort of be catered to locations or different years depending on what sort of the question or the main issue is. So for example, bleaching. And engaging in that it engages a lot of the community from sort of a ground level. And importantly, it's not just a sort of raising awareness campaign, like it is to provide sort of meaningful scientific data and research infrastructure. Very briefly, how does it work? This ugly map here is our sort of reef priority schedule. So every single reef is ranked according to the set of priorities for that year. And so, for example, the data from this goes into models fed directly to the COTS team. And so the COTS reef, their target reefs for that year are high on the priority schedule. And so we can target other things as well, like thermal refugia, or where we think that which reefs will be particularly important for sort of natural recovery or restoration or whatever your question is. People capture photos, very simple method. Basically, people go out and go on snorkel with GoPro, take photos about 3 meters from the reef, take a photo, kick 10 times, take another photo in that. So you do this 20 times and you've got a survey. Sorry for butchering that. And then once you've got these, ideally each image is geotagged, but at very least the site where they were, the one point on the site is geotagged. That's uploaded to a platform, and a few sort of basic questions are answered. Did you see COTS? Was there bleaching? And then you do that several thousand times, and you've got a whole bunch of photos across the reef. The next stage is how do you get information from those images? And so there's two main methods at the moment. One is purely by AI and one is by AI and volunteers. And so people start to have heart palpitations and clench up when they see analysis and volunteers in the same sentence. But give me a chance. So the AI has built a semantic segmentation model with SegFormer. That's the current model, but that might change. And the volunteers, it's a website that's on the Citizens of the Reef website. It's a sort of fun, engaging, slightly gamified, there's leaderboards, and basically they get an image and the AI will draw sort of an area around what it thinks is one thing, and then you click on that and one of 8 options. Is it plating coral, is it branching coral, is it sand, whatever. There's a few very basic questions. And so the people doing this are essentially volunteers, which is whoever anyone wants to, so all of you. But also it's in schools. So Nick from Citizens is running a very large school program, so he's got thousands of school kids doing this, and that's constantly growing. There's corporate partners, so all these companies here are doing this as part of sort of their ESG commitments. and basically anyone who wants to. So the sort of reach of this process, this is a little bit old, but there's nearly 5,000 surveys done, over 100,000 images. I think just last year there was nearly 200,000 individual analyses done. And so there's clearly sort of an appetite for this, and this was done very cheaply, right, without much funding. And so there's clearly an appetite for this, and we can collect lots of information, and that's great, but does it work? And so that's what I'm going to talk about. So one of the key things that arose from the very initial discussions with Grompa when this was starting was identifying these key coral morphologies, right? And so we can validate habitat maps with this of plating coral, boulder, branching, these kind of key groups that will be important to different people for different reasons, recovery, vulnerability to COTS or for tourism or whatever it is. But people are interested in these key groups. And so our metric of how do we know the information we're getting is right. So the next slide, I'm going to show an extremely simple table that is, it's only got 4 numbers on it. But those numbers are just the difference between what the AI has given us back and what our sort of expert panel has said. And so the experts are trained scientists who are paid to do this. They're not volunteers. They're people who know what they're doing, and they're paid. And they go around every single image and manually draw around the coral groups and assign a label to it. And so then for each image, we know what's actually in it. And so the AI spitting out, so these are just the average differences between what the AI is telling us and what our known values are. And so, for example, for branching coral, say it's negative 1.5, and so the AI is underestimating branching coral by 1.5% of that image. And so that's an absolute sort of image amount, right? So if the experts say there's 10% branching coral in this image, the AI is saying 8.5. And if the experts say 50%, then the AI is saying 48.5. And so that is good, right? We somewhat arbitrarily chose 5, plus or minus 5% as that's a pretty reliable estimate. And so this is doing quite well. A few years ago, this is probably really exciting, but now you probably just shouldn't be surprised if you've been paying attention at all. What is slightly more interesting is how do the human volunteers go. And so, somewhat surprising to me, plating and boulder coral, they're actually smashing it. They're really good, which is maybe some key learnings there. And so they're really good for that. Branching coral, they're a little bit high, so they're overestimating in general. And I think that's because that apparently the general public are not good at identifying dead branching coral. And so when it's just a dead coral, they kind of just see the shape and think that's live, which maybe is, there's something bigger there. And so how do we improve this? And so photo quality is a big one, which I'll talk about in a second. But it may also just be a training thing. And so if you provide a little bit of training for these people, say this is what dead branching coral looks like, then maybe people will do better. And a whole bunch of other stuff. So it's constantly improving the system. We're constantly doing a lot more. So there's a lot more that can be kind of added into this. But for now, conveniently, this the AI is very good at what the human volunteers are not so good at. And so you can kind of take the good from each one and get nice estimates of coral cover for each of these categories for each image and kind of put it into one funnel, and you've got some nice results. So sort of another obvious question, I guess, is total coral cover. And so if you lump all these categories together and get total coral cover, what can it do there? And so a key question here is, well, how many people do we need to analyse each image, right? If we need 1,000 people to analyse every single image to get a semi-reliable result, then maybe the system's not going to work because it's just, then it becomes not scalable, which is the whole purpose of it. And so this y-axis is just the sort of traditional measure of precision, so standard error over mean. And again, this is every study will use a different value. 0.2 is pretty common for sort of to capture the variability in marine benthic areas. And the x-axis is how many people do we need to sort of get a reliable level of precision, right? Do we need 5 people to analyse every single image? Do we need 10 people to analyse every single image? Do we need 15? And you can kind of see by about 6 or 7 analyses per image, you get down to a level of precision that you sort of start to be confident that you're capturing the variability in responses. And so if we say round up, say you get 10 people to analyse each image, then that, based on the sort of level of engagement we've had last year, that's actually achievable, which is nice. There's 1,000 different ways you can slice and dice all this data, but one of interest is, well, how does it do? That's just the average of all images, but what about for reefs where there's low coral cover or very high coral cover? And so this is just essentially the same data but divided into these 10% coral cover bins, right? And the accuracy number is the same metric as I described before. And so you can see in the middle it does very well. At these very low coral covers, it's overestimating. At the very high coral covers, it's underestimating, but that probably doesn't matter as much as the low ones. Is more interesting. And so this is obviously very common for this kind of data because it has to be between 0 and 100. You can't have negative coral cover values. And so people are either, sorry, that's a really terrible graph. Don't stress too much. Just look at the very clear distribution there. Is that if, for example, if an image has 1% coral cover, the system is either going to get it correct or it's going to be an overestimate. And so then, in the middle where they balance each other out, it can sort of overestimate coral cover at low images and underestimate at high coral cover. And this again largely is the images that it's not doing so well on is ones with pretty bad photo quality. And so the problem with the AI is that it can kind of give you these insidious errors where it will give you an answer, but you don't know if it's correct or not, right? And so you get all these images in there that, someone's taken it too far away from the reef, or it's really bad visibility, or it's just a bunch of dudes on the boat afterwards drinking bintangs, taking selfies. And so how do you get rid of those images? And so the human element of this can be useful in 3 ways. And so one is there's a bad image button on the system, and so they can just flag them, you can get rid of them. 2, they can say, I don't know. And so if a lot of people are saying, I don't know what this thing is, it probably suggests that the photo's not that great. And 3rd, their variability in their responses gives us a good indication of how good the photo is. So when some people say it's 10%, some people say it's 90%, generally that means that it's a pretty bad image. And so if you can create a filter based on the standard deviation in the responses of the volunteers, then you can filter out some of those images and just look at the first row, you can kind of get it down to an accuracy that then is useful for management purposes. All right, I'm nearly done. Benefits is why do this kind of this whole system, right? I said cost-effective tool, so it's cheap, right? It's much cheaper than paying a whole bunch of scientists to go out and do this. I guess you can kind of piggyback other things onto it, so it's cheap research infrastructure. So we had over 100 boats, I think, go out last year, and they go out to all these remote areas, and these are funded by tourists paying for it, or millionaires with yachts, or corporations. And so you get this kind of cheap research infrastructure that, I need to go collect some eDNA samples out here, or chuck an acoustic receiver off the side of the boat. You can kind of piggyback that onto these things that are going out to all these areas already. As a lot of people have already spoken about here, the photos are a permanent record, so you can go back and analyse them with AI for something completely different later and look at trends and blah, blah, blah. Engages and empowers the community. So again, there's a lot of traditional owners involved in this, a lot of just people who have vested interest in their local reefs who then can sort of become involved and have a sense of agency in this kind of constant onslaught of negative climate change media. They can kind of feel like they can actually do something. And slightly different, I think this is a really important one that I think we sort of as an industry do a really bad job of, is engage people who otherwise wouldn't be engaged. And so it's very easy to stick to our bubble, right? Everyone's very passionate here. But when I talk to friends and family about this kind of thing, who in completely different fields, they say what's coral bleaching or what's coral? They think it's a rock, literally they have no idea. And so you've got thousands of school kids doing this, so it's kind of a gateway drug to conservation. And you've got, HR managers at Microsoft and accountants in New York for, Salesforce and Virgin doing this, who completely would otherwise just not care or be completely unaware. And so this kind of gets out of this bubble that we're all in, which I think is important. So last slide, I promise. So it's a way, a scientific tool to mainstream conservation. This combination of this decentralized volunteer workforce plus leveraging AI, you get good data very cheaply. Importantly, the number of analyses needed, so the number of people involved, is actually reasonable based on the engagement we've had. It's actually probably achievable. Humans can still be useful in a world dominated by AI. This is a bunch of people involved. Scan the QR code. We'll go to the Citizens of the Reef website where you can analyse photos on your phone right now. It's live, right? Yeah. Do that because I didn't put Citizens of the Reef logo on here and Andy will slap me. All right, thank you.
Thank you, Chris. I'm mindful that this room is booked for the next set of talks. We've got time for one question if anyone wants to sneak something in. Do you want to come on up to the mic? Got to do the strolls.
So that's really cool, lots to like. Just a question, when you're talking about coral cover, are you just talking about coral cover of the image or more broadly? Have you tried to do anything to translate that to something else? Because I'm guessing there's a lot more information you require to go beyond that.
Yeah, so that's one of the many things that I didn't include in this. So that's all per image, and then I'm doing a whole bunch of analysis at the moment on essentially how many images we need per site and per reef to get a sort of representative understanding, right? It's like, first, can we extract information from the image? So yes, and then if we have
so that's work
50,
in progress.
100, and so as you get to the sort of site level, something more.
Yeah, because if you just go to the nice corner and take all your photos, you get a non-representative image at scale. So
100%. And anyone who's looked at the different methods of surveying reefs will very quickly realise you got 5 different methods of surveying a reef in the same time, and you'll get 7 different answers. Thanks.
Thanks, David, for a great question. Thank you, Chris, for a great presentation.